Okay, we are gonna solve the problem called TwoSum. Given an array integer nums and an integer target, return index of two numbers such that they do add up to target. So we have an array called nums which has integers, and we need to find a pair such that um, their sum is 9, right? So for example, the first one, as you can see, num of 0 plus num of 1 is equals to 9. Okay, um, got it. So okay, so each input will have only one solution. We can return it in any order. Okay, so got it. So I mean, one way we can do it, which is like the um, brute force approach, is we create multiple pairs. So for every value, we look at the other value. So 2 7, 2 11, 2 15, 7 11, 7 15, 11 15, which are all the pairs, and then we see if any of their sum is 9, and as soon as we find a pair for which the sum is 9, we return that. So that will be the answer, but the time complexity for that will be big of n square, which we don't want. We want to do something faster. Okay, yeah, so we want to make it faster than big of n square. So one point here which we can use is it's a pair and we have a target. So basically, if we look here, let's say we have 2. So when we reach 2, we basically want to look for 7, right? Because there are no negative values here, or there can be negative values. Okay, so then what we want to look for is either um, actually we only want to look for 7 because we need to add both the numbers. So yeah, so target minus the number. So 7, if 7 is there anywhere in this list, that means we have a pair. Similarly, if we let's say take 11, then we want to look for 9 minus 11, which is minus 2. So if minus 2 is there anywhere, that means that will be the result. So here the bottleneck will be finding if the other pair value is present anywhere in this list, and we can try to fix that using a hash map. So what we can do is we can create like a, let's just say hm, okay, which will be a map, and then what we can do is for value in in nums, hash map of value is equals to 1. Okay, now we'll use this hash map to do that find in constant time, because the lookup is big of 1. Now what we do is we do for and actually another thing that we can do is value, let's do index comma value in enumerate nums. The reason we want to keep track of index is in the end we want to return the index, not the value. So we do hm of value is equals to index. Okay, now what we do is we do for index comma value in enumerate nums, and I can see some redundancy here, so we can probably try to optimize that later. So nums, the new target will be I'll just say underscore target will be target minus value. That is our new target, and if the new target or temporary target in hm, in this case what we want to do is return index comma hm of target. Okay, if it's not there, uh, it should not be the case. So that should give us the answer. What happened? Okay, key error 9. Oh, it's underscore target. Okay. Okay, got it. So we cannot have same values here, you can see. So in that case, uh, basically we cannot have the same value. So values are not repeating. What? What? So new target should not equals to value. Okay. We can. We can. Okay. Yeah, so that should be the solution. Basically, what was happening was, in hash map, we do keep track of a key value. So let's say we had this 3, or let's say we had target as 9 here. So if we find 2, we will keep finding another 2 here without this condition. So what will happen is, let's say we have 2. Now we are trying to look for another 2 in our map. So since the same 2 can be present, we'll basically look for that 2. So you want to make sure that we are not looking at the same value that we have already considered. That's why we are using index key here. Okay, if this array was sorted, that would have been a different way. So this is like a linear time solution, but if we want to do like a n log n or logarithmic kind of a solution, we can do that as well. In that case, what we can do is we can do nums dot sort, and then we can do let's say pointer 1 pointer 2 is equals to 0 comma 1, and then what we can do is and let's just create another value called okay, we don't have to. And then what we'll do is, while p1 is less than p2, we go here, and then if so nums of p1 plus nums of p2 is equals to, or I think the better is, let's just create a temp variable like this, and we say if temp is equals to target, want to return p1 p2, right? If temp is less than target, that means we want to keep on increasing the value, so we do p2 plus equals to 1, else we do p1 plus equals to 1. So in the end we should have an answer for this as well. I think it's like a 0 and 2. Wait a second. We're returning 0 and So what I wanted to do is, for this one, I start from 2 7, find the value. Just think about this one. So if you sort it, it will become. Oh, okay. Since you have sorted it, the order changed, and that's why the index changed. Okay, so since we want to return index, I don't think we can do it this way. Cool. Then the first solution works. Thank you.